Hi. In this video, we'll discuss the few problems of the polynomial that are essential for the NTSE. I hope you have gone through the theory in the previous videos. Let's do a few problems over here, good problems, which will clear your basic concepts. First problem is if x plus under root of x plus under root of x plus under root of x and so on, the value is 2. Find value of x. Solution. Whenever we arrive this kind of a problem, when the series is of infinite, we probably jumbled about how to solve this kind of problem. See here, this is x plus under root of x plus under root of x. This is goes for the infinite times. This is very important. Now, if we subtract, if we eliminate one of the x from the infinite, will it make any difference? No, obviously not. So, can I say, no, if I take this quantity over here, x plus under root of x plus under root of x plus under root of x and so on is 2, right? If I take and square root both the side, if I take the square root both the side, these quantities become root 2. Now see carefully. I'm writing again the same equation again. This equation here. X plus root x plus root x plus root x is 2, right? Now compare these two quantities. Are they identical? Yes, they are identical because you don't know where is infinity. These two quantities are identical. The value of this quantity is now root 2, right? Now, can I cite this? X plus root 2 is equal to 2, right? Now I can say immediately x is equals to 2 minus root 2. Hence solution is, well, if x is 2 minus root 2. There are other ways to solve the problem. Maybe your teachers might have told you to solve by making a quadratic equation. That there you get the two solution. One solution is obviously would be a 2 minus root 2, and definitely another solution would be 2 plus root 2. And obviously 2 plus root 2 would not satisfy this equation because this quantity has to be positive. So this is the easier way. We got the single solution which is correct. There is another way to form a quadratic equation and solve it. So that is the easy method, but again we get the two solutions, we have to judge which is correct or not. In this way, just get the one solution which is always correct, right? Just have a look to the solution. X plus this quantity, we said that this quantity is similar, so if you take the under root, you get this quantity similar over here, that is root 2, right? And we have solved the problem. Now next problem. If alpha and beta are zeros of quadratic polynomial kx square plus 4x plus 4, find the value of k such that alpha plus beta whole square minus 2 alpha beta is 4. Now solution. Let's understand the problem first. If alpha beta are the zeros of a quadratic polynomial which is given, we would find the value of k such that alpha plus beta whole square minus 2 alpha plus beta is equal to 24. This is 24. You got the problem? Let's write the quadratic polynomial. This is kx square plus 4x plus 4. In the quadratic polynomial, we know the value of alpha plus beta, which is coefficient of minus times the coefficient of x upon coefficient of x square, minus times coefficient of x upon coefficient of x square, that is minus 4 upon q, right? Alpha beta product of the roots is constant upon the coefficient of x square, that is 4 upon. Now we have to find the value of k such that the given condition is alpha plus beta minus 2 alpha beta is equal to 20. Now let's apply here alpha plus beta whole square, alpha plus beta whole square minus 2 alpha beta is 24. Now let's put the value here. This minus 4 upon k whole square minus 2 alpha beta is 4 upon k is 24. We got an equation here. Now let's try to solve this equation. This is minus 4 upon k square is 16 upon k square minus 8 upon k is equal to 24. Let's take the LCM and simplify this problem. Let's take this LCM here. K square 16 minus 3k is equal to 24. Now this becomes 24k square plus 8k minus 16 is equal to 0. Let's take out 8 common from the three terms. It becomes 3k square plus k minus 2 equal to 0, and which is further equal to, let's split the middle term. It becomes 3k into k plus 1 minus 2 times of k plus 1 equal to 0, which is k plus 1 into 3k minus 2 equal to 0. Therefore the value of k is either minus 1 or 2 upon 3. Hence this is the answer. Both the values satisfying the equation. Therefore we can say the answer of this problem is k is minus 1 or k is 2 by 3. Now the next problem. Alpha, beta, gamma are zeros of cubic polynomial x cube minus 12x square plus 44x. If alpha, beta, gamma are in AP, find the value of C. Now solution. The question is, it is a cubic polynomial. Obviously it has 3 zeros. It terms as alpha, beta, gamma, and it says that alpha, beta, gamma in the AP. AP means arithmetic progression. So we have to find the value of C. Now arithmetic progression means these three roots have a constant difference between the consecutive roots. Say I can say alpha minus beta, the difference between these two roots is equal to difference between these two roots. This is the condition. Now the cubic polynomial, we know that sum of the roots is, that means sum of the roots means alpha plus beta plus gamma. We know that the sum of the roots is minus times the coefficient of x square upon coefficient of x cube, that is 12. Alpha, beta, gamma, product of the root is constant upon coefficient of x cube, and alpha, beta, beta, gamma, and gamma alpha is coefficient minus plus times of coefficient of x upon x cube, that is 44. One condition is also given, that these are in the AP. Now let's take the advantage of this condition. AP means that they have a common difference. Let me assume that alpha be a minus d, beta be a, and gamma be a plus b. AP means that they have a common difference. I have assumed this alpha, beta, gamma. Now first, applying the first equation, alpha plus beta plus gamma means a minus d plus a plus a plus d is 12. That means 3 times of a is 12, a is 4. This is one thing we got, right? Next, alpha beta gamma is minus c. Alpha beta gamma means a minus d, a, and a plus d is minus c. It means a square minus d square into a is, we know the value of a here, which is 4. We don't know the value of d. Let's calculate the value of d also using the third equation. Third equation was alpha beta, beta gamma, and gamma alpha is 44. That means a minus d into a plus a into a plus d, and a minus d into a plus d is 44. Now this is a square minus ad plus a square plus ad plus a square minus d square is 44. This AD is cancelled with this AD. A square plus A square plus A square is 3A square minus D square is 44. We know the value of A here. A was 44. We have already calculated. Let's put the value of A here. 3 into 4 square minus D square is 44. 4 square is 16. 16 3s are 48. Minus D square is 44. And D square is 4. And thus D is 2. Or you can say plus minus 2. This will not make any difference because we have assumed the term A minus D, A and plus D. Minus sign just reverse the AP thing. Therefore, we get the values as D is, let's take plus 2. We got the value as A minus D, A and A plus D. A minus D become, the value of A was 4, right? The value of A become now 4 minus 2, 4 and 4 plus 2. That means 2, 4 and 6. These are the values and these are the roots of the equation. Now the product of the root is minus C, right? Product of the root was minus C. That means if you multiply this all quantities, 2 into 4 into 6, that is product is minus C. So C is minus 48 as the answer. Next problem. This is very important problem and very interesting problem. Two non-negative real numbers x and y are such that 2x plus y is 5. The sum of the maximum and minimum value x plus y. Now, problem is we have two real numbers which are non-negative. This is x and y. We need to find the value, maximum value of x plus y and minimum value of x plus y. And again the sum of the maximum and minimum value. The given parameters are 2x plus y equal to, I can say 2x plus 5, 2x plus y is 5. Can I say this x plus y equal to 5, right? Maximum value of x plus y can be, it is sum of the two quantities x and x plus y is 5. Maximum value of x plus y is 5. The sum of the two quantities is 5. I can say the maximum value of x plus y can take is 5 and x is 0. This is the maximum value. Now for the minimum value, 2x plus y is 5. It means I can say 2x plus 2y minus y is, this is twice of x plus y minus y is 5. Now minimum value of x plus y is when y is 0. Minimum value of x plus y is when y is 0, right? Therefore minimum value of x plus y here is twice of x plus y equal to 5 and x plus y equal to 5 by 2. This is the minimum value. Why is the minimum value? Because this quantity has to be maximum. The maximum non-negative quantity is 0. We got the maximum and minimum value. This was the maximum value, that it was 5, and here is the minimum value, that is 5 by 2. There was sum of maximum and minimum value here is 5 plus 5 by 2, which is 7.5. Hence the next problem. Let's take one more problem. If x is under root of 2 plus root 2, find value of x is to power 4 plus 1 upon x is to power 4. 4 upon x is to, you know the value of x here. See here how to solve this kind of problem, right? Now squaring both sides, x square is 2 plus root 2, right? X square minus 2 is root 2, right? You know the value of x square here. 1 upon x square is 1 upon 2 plus root 2. Now let's rationalize this. 1 upon x square. I'm rationalizing this denominator. Rationalizing coefficient obviously here is 2 minus root 2. It becomes 2 minus root 2 upon a plus b into a minus b is a square minus b square, that is 4 minus 2, which is 2 minus root 2 upon 2. This is 1 upon x square, right? Now we got the value of x square, that is 2 plus root 2. We know the value of 1 upon x square, that is 2 minus root 2 upon 2. Let's rewrite the value like x square plus 1 upon x square is 2 minus plus root 2 plus 2 minus root 2 upon 2, right? Let's take the LCM here, or let me write precisely here into 2 times. That will be more better. X square upon 2 upon x square. This will help us a lot. Now x square plus 2 upon x square is 2 plus root 2 plus 2 minus root 2 minus root 2 and 1 plus root 2 are cancelled out. Is 4. X square upon plus 2 upon x square, value here is 4. We need to find the value of x4 plus 4 upon x4. We got the value of x square plus 2 square. Let's square again. X square plus 2 upon x square is 4. I'm doing the squaring. Now this will give this a plus b whole square is a square plus b square plus 2ab. A square is x to the power 4 plus b square is 4 upon x4 plus 2ab is 2 times of x square into 2 upon x square, right? 4 square is 16. Now this x square will be cancelled out. 2 into 2 is 4. It means x4 plus 4 upon x4 plus 4 is 16. Now x4 plus 4 upon x4 is 16 minus 4, which is 12. Hence the answer. We got the value of x square plus 1 upon x4 is 12. Thank you. Please give your feedback.